All right, well, welcome back, and we're going to continue our discussion on 6.3. This is day 2, or sometimes they call it B. Um, what we have here is we are continuing our discussion on binomial distributions, and specifically we're talking about its shape, center, and variability. When we talk about the shape, it is important that you know how to make a histogram with binomial distribution, how to graph this. That would be good. Other things that you should know how to do is how to find the center, like with any distribution, we want to find the center, and also the variability and spread. When we're talking about binomial distributions, we can figure this out by taking the probability of the event occurring times the number of um, trials that we have in the event. In the same manner, if we talk about the standard deviation of a binomial distribution, we can take the square root of n times the number of the probability times the probability of the failure of that event happening. Interpretations, make sure you say out of many trials, because when we talk about binomial distribution, we are talking about many trials, similar when we're talking about any type of probability. So one thing that you also want to know how to do is how to find binomials using your calculator. There is a cool thing known as binomial CDF and binomial PDF. Sometimes these are confused. They're a little bit different than the normal PDF and CDF in that when you talk about binomial distribution, it's when the event X is always going to be less than or equal to the K value. That is important. K number of successes. And so you're going to go to your, well, I'll show you this in a little bit, but go to binomial CDF, you put in your N, that is your label, you're going to put your P, which is your probability, and K is the number of successes. Now, when you talk about binomial PDF is when it's going to be equal, the probability of equaling that amount of successes. So this is less than, similar to a percentile, I guess you could say, for the CDF. And this is where it's equal. So binomial PDF, N is a label, probability, and then K being successes. All right, so let's try out some of these problems. So are you more likely to win a random drawing if you crinkle a paper that contains your name before putting it into the drawing box? That's always an interesting fact, or a thing that people wonder about. A curious student conducted a study to investigate. The student took 100 equally sized slips of paper and crinkled 25 of them and putting them into the box. After mixing well, they asked an uninformed person to select a winner at random. The student noted if the slip was crinkled, the slip was returned to the box, mixed well, and asked another uninformed person to select a winner. This process was repeated 10 times. Um, let y be the number of times the crinkled paper was selected. All right, so y is the number of, so is this a binomial distribution? Let's check this out. Well, first off, is it binary? If it's a binary, that means that, well, I think it is yes, because either you pick crinkled paper, or not. It is independent as there is replacement. So, uh, and it's being mixed well. All right, it was returned to box, mixed well, and mixed well. So each crinkled one had the same probability of being chosen from the other ones. There is a set number. All right, this is going to be repeated 10 times, and the probability appears to be the same because it has a 25 out of 100. All right, I have a chance of killing one, so that's going to be a 1 out of 4 chance of selecting crinkled paper. And so yes, all right, this is a binomial setting, or binomial distribution. And binomial distribution, I guess, both. All right. So we're going to use technology to make a histogram of the probability distribution of y, and then we're going to describe its shape. All right, so in doing so, in doing this is we're going to go through and figure out what these different values are going to be and going to distribute this. And so to figure this out, we have to figure out some different values. And so we're going to take our calculators. And so what we're going to do here is we're going to use our calculator to figure this out. And so what we're going to here is we're going to go to our lists. And in our list, we are going to take this, all right, go to stat, stat, and we're going to go to our edit. And we're going to clear out these different lists because I have some other stuff in here. So if you have any other things, clear out list 1 and list 2. And in these different ones, in order to make our histogram, we're going to say, okay, we have 10 chances to win here. So I'm going to go back to here and think about, okay, what do we have here? Well, we have 10 trials, okay, and we're looking for pieces of paper. So either you get a piece of crinkle paper or not. Each probability is 1/4, okay, because it's 25 out of 100. And so over here, what are the chances? So can you get 0 crinkle paper? Yes, out of the 10 trials. So you can be at 0 would be 1. You can get 1 piece of paper. You could get 2 pieces of paper. You could get 3 out of 10. You could get 4 out of 10. And really, looking at all these different ones, I'm listing all the possible outcomes that you could have from these different pieces of papers, all right? And so we have 11 different outcomes from here. Now from this is the cool part. We're going to go up here and go to list 2. And if you've ever done this before, we're actually going to put in an equation here. And in this list 2, we're going to go to second distribution. And we're going to be using our calculator. We're going to go down to I went down here, into a binomial PDF. All right, so if we go up here or press the alpha A button right there, and I'm going to take this. Now from here, it's going to say, well, how many trials do we have? Well, we have 10 trials. Our probability in this case is going to be 1/4. All right. Now the thing is, what is the X value? So what is our K value? What is the success values we're looking at? Well, our successes change. And actually, to make it easy for us, we're going to actually take instead our list, and we're going to actually put in list 1 in there, because what's going to happen is that it's going to take every one of the values of list 1 and calculates the probability for us. And we're going to paste that here. And so we're going to do a binomial PDF with, all right, 10 trials, all right, or 10 puzzle trials of 1/4 probability using each one of these. Now, if I press enter, voila, and here's all the probabilities. So the probability of getting 0 piece of paper is 0.05, so about 5%, about 19%, 28%, 25%, and so on and so forth. And it gets really, really low. Collecting all 10 would be a very, very small number. Now from here, if you go back to second stat plot, now we're going to create something here. All right, we're going to do a stat plot here, and we're going to punch in this right there. And I'm going to go to 1, and we're going to turn it on, and we're going to do a histogram. And our histogram is going to look like this. And in this one, we're going to have our list. List is going to be list 1, but our frequency, all right, I'm going to clear this, and that is actually going to be our list 2. Our list 2. And we're going to have that. And so we have our histogram here, and that's going to be on. We want to go to our window. Let's check out our window here. And we're going to change this up. And if you go to zoom 6, you can kind of get a better, oopsies, better window here. I'm going to change my window again. And so we're going to go from 0, and we can get up to 10. I'm going to go a little bit farther. I'm going to go to 11. We'll go by ones right here. And in our histogram, well, our Y values are going to be really small percentages. So I'm going to go 0 to 1. Maybe we'll go 0.5 because I don't think anything's past 50%. And we're going to go by 0.1s and for our scale. And now let's graph this. And that is our histogram that we see right here. Awesome sauce. And so I'm going to take that histogram. I'm going to put this right here. And that is what we see. All right, and that's what we got. And so we have here, using the following part, and we're going to describe this. And this appears to be, and maybe you could say slightly skewed to the right. All right, so I'm going to say this slightly skewed to the right. All right, slightly skewed to the right, and that's what that distribution is. So the probability distribution of y is slightly skewed to the right. And now let's calculate and interpret the mean of y. All right, the mean of y. Now, how do we do that? Well, we can calculate the mean and the standard deviation by taking all these values. We're going to use our calculator again. And if you go over here and you go to your stat button, we're going to calculate this. And now we're going to take this right here and we're going to take list one and we have a frequency. Using list one, once again, we're going to take and we're going to use list two again. And those are our probabilities. So it's kind of like doing with random variables, discrete random variables. And we're going to figure out what is the stat on this. And so right here, this gives us all of our information here. And so what do we have? Well, right here, it says, okay, whoops, for our mean and probability, and figuring this out. How can we interpret this? Well, if we go back to this, I probably should think of this. What is the mean of distribution? Well, the center is calculated by, all right, n times p, and that's going to give us our mean, all right here. And so we're still looking for the mean of y. Our n value is we're taking 10, and the probability is going to be 1/4. All right, and if you take that, it's going to be 10/4, which you can see right here. Going through that is going to be 5/2, which is 2.5. And looking at what we have right here, and what do you know? 2.5. Cool. And so what does that mean right there? And I'm going to take this, and this is actually, I just calculated the mean down here of y. What that means is that after, all right, many, after many times in selecting 10, by selecting 10 pieces of paper, piece of paper, with a probability of 1/4, selecting a crinkled one, piece, we would expect 2.5 pieces of crinkled paper to be selected, right? And that's what we know. After many times of selecting 10 pieces of paper with a probability of one selecting a crinkled paper, we would expect about 2 pieces of crinkled paper being selected. And that's what we have for our average. That's what our mean of that probability is. If you keep on selecting things and you had a probability of selecting a crinkled paper, which is 1/4, we would probably expect to get about 2.5 pieces of paper. Now, to figure out the standard deviation of y, you recall the standard deviation of our random variable in doing so, our binomial distribution, is the square root of n times p times 1 minus p. And so in this case, it's going to be the square root of 10 times, we have 1/4, times 1 minus 1/4, which is 3/4. And that's going to give us our answer. Now, let's see what that's going to be. So if I take out my calculator, all right, we clear this, we take the square root of 10 times 0.25 times 0.75. And what we get? We get 1.369, 1.369. What do you know? It's the same thing we have right there. So cool. So what do we have in our two-parameter standard deviation? What that means is on average, all right, um, the number of crinkled pieces of paper, being selected out of 10 is, or typically varies, all right, typically varies by how much? Well, it typically varies by 1.369 from the mean, all right, which in this case is 2.5. So that's what we have. On average, typically a piece of paper being selected out of 10 typically varies by 1.36 out of 10. Okay, and that's what we have for this particular one. All right, and so that is what we got. Once again, talking about binomial distributions, how to find the center, how to find the variability, look at the shape, and make sure that we say out of many trials. All right, so after many times or many trials, we'll put in that. Selecting 10 pieces of paper with a probability of selecting paper, we would expect to get about 2.5 pieces of crinkled paper to be selected. An average number of crinkled pieces of paper being selected out of 10 typically varies by from the mean. And there we go. Good luck and God bless in the rest of your binomial problems.